Welcome back to my YouTube channel, Massa Tutorials. Alright, we are still on our analytic geometry and calculus, Math 102. Analytic geometry and calculus, Math 102. So, we are on the subtopic midpoint. Midpoint, that's the middle point. Midpoint of a line segment from point A, that's x1, y1, to point B, x2, y2. Again, midpoint, that's the middle point of a line segment from A, x1, y1, to point B, x2, y2. So let us consider this diagram. This diagram, very simple diagram. So I have my y-axis, then here x-axis, then we have here I have my point A, x1, y1, my point B, x2, y2, then we assume that the point M, that's the middle point M, is xy here. So get something here, then here too, the same thing. Alright, so now okay, so I have my 90 degrees here. Then here, we assume that we have a value here, an x value, that's x1. Then here, we have an x2. An x2 here. Then we have point P. Point P, which is, let us give another value, y value here, that's y1. Then here another value here, that's y. Then another value here, we assume to be what? y2. Right. So that's that. So let us assume that there's a point Q here, then a point P here. So this point Q, we have what? x2, then what? y. x2, then y. Right? Then we assume that we have another value for the x-axis, which is what? X. We label it as x, right? We label that as x. Wait. So here is also 90 degrees. Alright. So we have right angle triangle, then right angle triangle. So point A, that's x1, y1. Then point P, which is what? X, then what? y1. X, then y1. Then point Q, x2, y. Then point B, x2, then what? y2. x2, then y2. x2, then y2. Alright. So this is a diagram for the midpoint. Very interesting. Very interesting. Point A, x1, y1, point P. We have x, then what? y1. X, then y1. So don't forget, we have x, then y1. Then we have the midpoint, which is what? X, y. The midpoint, xy. The middle point, which divides this line segment, or the straight line AB, into two equal parts. So that's M. We denote it as what? M. That's the xy. Then point B, x2, y2. Then point Q, we have what? x2, then what? y. Then point P, x, then y1. Alright, so listen. Let us consider the diagram above. So the diagram on the board, right? So we are considering this diagram on the board. If this M is the midpoint of the line segment AB, if M is the midpoint, is the middle point of this line segment AB, Then we have equal distances along the x coordinates. Again, if M is the midpoint of line segment what AB, then we have what? Equal distances along the what? Along the x coordinates. We have equal distances along what? The x coordinates. So from here to here is the same distance from here to here. Right? Then from here to here is the same distance from here to here. You get equal what? Distance. That's middle point. If M is the midpoint. Alright. So we are considering the diagram on the board again. If M is the midpoint of the line segment AB, then we have equal distances along the x coordinates as follows. So equal distances along the x coordinates as follows. So I have this, the distance of AP, the distance of AP, which must be equal to the distance of MQ. The distance of MQ. So the distance of AP must be equal to what? The distance of what? MQ. Because this, when you consider, they are what? On the horizontal axis, which is what? The x axis, right? So the distance of AP must be equal to what? The distance of what? MQ. So now let's see. The distance of AP. Alright, we didn't find for the distance of AP. This one is a smaller value and this one is a bigger value, right? So it means that I can subtract x1 from what? X. So I'll get what? I'll get x minus what? x1. I'll get x minus what? x1. Then here, we can get the y-axis, that's the vertical axis. As I have y1 then y, right? This y1 is smaller than y because when it is increasing, the values would increase, right? Alright. So when you are climbing upwards, the values would increase. So I have what? Y minus what? y1 here. We can subtract y1 from y. Then here also, the same thing, I can subtract what? Y from what? y2. So y2 minus what? Y. Then here, because x is smaller than x2, we can subtract this one from that. So I'll get what? x2 minus what? X. Very, very simple. Very, very simple. Very, very, very simple. Again, x1 from what we've done previously, that's the same thing, but this time we are building up to what? Midpoint, right? So you can subtract x1 from x. Why? Because when you are moving towards the what? The y-axis, the values will be what? Increasing. Here, y-axis at the right hand side, that's positive y-axis, right? So when you are moving to the right side, it is what? The values are what? Increasing. But when you are moving to the left hand side of the x-axis, the values are what? Decreasing. So now here, we are moving to the the right side, sorry. We are moving to the right side. So the values, the x values will be what? Increasing. So now, this one is a smaller value, but this one is a what? It's a bigger value as compared to this. But when you come to this is greater than that, right? So x1 and x, when you are comparing, this one is the greater value here, or the greatest what? Value. Greater than great, right? Aha. So I can say that x1 is smaller than x, then x is smaller than x2. x2 is greater than this, then this x is greater than that. Alright. So that's why we had x minus what? x1, because I can subtract x1 from what? X. Then here also, from the vertical axis, that's the y-axis, when you are increasing, when you are going upward, then the y values will be what? Increasing. The y values will be what? Increasing. So you can subtract y1 from y, then likewise you can also subtract what? This y value from what? y2. So we have what? Y minus what? y1. The difference then you find for the distance here along the y-axis. then here also it applies here. You can subtract y from what? y2 along the y-axis. So you get the distance. That's y2 minus what? Y. So we have the distance of AP equals the distance of what? M. So we are saying that what? If M is the midpoint of the line segment AB, then we have what? Equal distances along what? The x coordinate. So this one is the equal. We are considering the x coordinates. Equal what? Distances along the x coordinates. So the distance of AP, which is what? X minus what? X1 equals the distance of MQ. So M then Q is what? X2 minus what? X. Right. So now here we want X. We want X. So we will make what? X the subject. We have to make X the subject, please. So if you are making X the subject, here is X, then here is negative X. Make sure to send this one to the left hand side, so that when this one negative X crosses the left hand side, to what? The sign will transpose. That means you get a positive sign. So I'll get what? X plus X, which is equal to this one 2 goes to the right hand side. So I'll get X2 plus what? X1. So here I'll get what? 2x being equal to what? X2 plus x1. Right. So 2x divided here by 2. That's the coefficient of x. So here also x2 plus what? X1 all on what? 2. So I'll get x being equal to what? X2 plus x1 on 2. So that's the x value for this midpoint. So please watch it very carefully. It's very, very simple. Very, very simple. All right. So we are moving on. So you can write this one. Somebody can prefer to write it as x value must be equal to what? Half of what? X2 plus what? X1. Since addition is commutative, you can just interchange half x1 plus x2. It's nothing. They are the same because addition is what? Commutative, right? So that's it. Alright, so let's continue. So we have our x being equal to what? X2 plus what? X1 all on what? 2. So similarly, we can do the same thing to the what? To the y coordinates, right? Similarly, we have equal distances. That's equidistance, right? So similarly, we have equidistance or equal distances along what? The y coordinates, along the y coordinates as follows. So let's see. So let us write it here. For x, we had what? X1 plus x2, right? Okay, then x2, x1 all on 2. It's the same thing. So now we are dealing with the y coordinates now. Similarly, we have equal what? Distances along the what? The y coordinates as follows. So it will be what? The distance of what? PM. The distance of PM must be equal to what? The distance of QB. The distance of PM, equal distances. So the distance of PM, you can see along the y-axis, the same thing. So the distance of PM will be what? Y minus what? Y1, which is equal to the distance of QB, which is what? Y2 minus what? Y, right? So now, here we want y. We are making y the subject because we want the y coordinates. So we are making y the subject. So making y the subject, we send this one to the what? To the left hand side because it's negative. So when it crosses, it becomes what? Positive. So I'll get y plus y, which is equal to, here is y2. So this one is negative y1. When it crosses, you get positive what? y1. So y plus y, I get what? 2y, which is equal to y2 plus what? y1. So 2y all on what? 2. You are dividing both sides by the coefficient of y, which is what? 2. Then here, y2 plus y1 all on what? 2. So I have y being equal to what? y2 plus y1 all on 2. So this one too, you can write it as what? Half y2 plus what? y1. It's the same thing. You can also write it as half y1 plus y2. It's the same thing. So y must be equal to what? y2 plus y1 all on 2. Very, very simple. Very, very simple. Very, very simple. Very, very simple. So that's it. So kindly watch it very carefully. Alright, so let's proceed. Let's proceed. Let's proceed. So we can see that finally we can write our midpoint formula down. So finally we obtain the midpoint. So finally we obtain the midpoint. We obtain the midpoint formula. We obtain the midpoint formula for a line segment. So finally, we obtain the midpoint formula for a line segment as m equals what? As m, that's x2 plus x1 all on 2, then y2 plus y1 all on 2. So from the diagram, you can see that m is what? X, then y. And you know that x is what? x2 plus x1 all on 2, then y is what? y2 plus y1 all on 2. So in place of x, we substitute what? x2 plus x1 all on 2 as shown. Then y, in place of y, we substitute what? y2 plus y1 all on 2. So finally we get what? The midpoint formula as that. So if they ask you to find for the midpoint of 2 points, find for the midpoint or the middle point of 2 given points, or a straight line, a point joining what? A straight line, right? So then you quote this formula for the examiner or for the lecturer before you start solving. So that's the midpoint formula. Midpoint formula is giving us what? x2 plus x1 all on 2, then what? y2 plus y1 all on 2. You can see in other books as the midpoint formula is giving us what? Half what? x1 plus x2, comma, then half y1 plus y2. It's the same thing as that. That's correct. So kindly watch it very carefully. Alright, so let's start with examples. So as we have been doing, I solved 3 examples, then I give you some to try. So now let's see. Example. It says what? Show that the equilateral with vertices P 1, 2, Q 4, 4, R 5 9 and S 2 7. It's a parallelogram. It's a parallelogram. It's a parallelogram. By proving that its two diagonals bisect each other. So show that the equilateral with vertices P 1 2 Q 4 4 R 5 9 and S 2 7 is a parallelogram by proving that its two diagonals bisect what? Each other. So you are showing that this is a parallelogram by proving. So if you want to show that this is a parallelogram, you have to prove that what? The diagonals bisect what? Each other. And you know that bisecting a line means what? To divide, right? So to divide a line into two equal what? Parts. That's geometric construction, right? To divide a line into two equal parts. So it means that this is what? M, the midpoint. So from A to B, we have equal distances. Then here to do the same thing, from this end to B, we have the same thing, equal distance, right? So this one, that makes it what? This is the perpendicular bisector, which is 90 perpendicular bisector, or that's a bisector. Sure. So bisecting a line means to divide a line into two equal parts. So they said by proving that its diagonals bisect what? Each other. Now we are talking of parallelogram here. You can ask yourself, what's a parallelogram? A parallelogram is a plane figure or a plane shape with what? Two opposite sides what? Equal. Two of its opposite sides are what? Equal. So we have this and that, the opposite sides equal. So that's one. Then we have that. That's the opposite sides to are what? Equal. So we have a parallelogram. Then we have what? These opposite sides, they are what? Parallel. They are parallel. So the question says that we should prove that they bisect what? They bisect each other. So how do we prove? So now let's see. Let's start by proving and let's see. So we have something, let's draw a sketch small. So y-axis, then my x-axis. So we have something as that. So point P, which is 1, 2, then point Q, 4, 4, then point S, 2, 7, then point R, 5, 9, right? So we want to show that the diagonals, they bisect each other, right? The diagonals bisect each other. So if you want to show that the diagonals bisect each other, then listen, watch and listen please. If the two diagonals have the same midpoint, if the two diagonals, that's the diagonal from this point P to this point R, we get what? A diagonal. Then from this point Q to this point S, we get what? Another what? Diagonal. So if these two diagonals have what? The same midpoint, then that means what? They bisect each other. Again, from P to R, from this point P to this point R is the first diagonal, or you can say second diagonal, any one of them. Then from S to Q, or from Q to S, that's the second diagonal. Now, if they have the same midpoint, you find for the midpoint of SQ or QS, then you find for the midpoint of PR, then you get the same midpoint or the same middle point, then that means this parallelogram or this diagonal bisect what? Each other. The two diagonals bisect each other. So if the two diagonals have the same midpoint, then they must bisect what? Each other, as shown. So therefore, using the midpoint formula, we find the midpoint of the diagonal PR. So we have to find for what? The midpoint of this diagonal, what? PR. So midpoint of this diagonal, what? PR. So midpoint of PR. So let's write it as this, M bracket PR, right? So now we have what? X2 plus X1 all on 2, then Y2 plus Y1 all on 2. So the midpoint of PR, which is equal to, we can label here X1, Y1, then here X2, then what? Y2. Now, X2 is 5, then plus X1 gives what? 1, all on 2. Then Y2 gives 9, plus Y1 gives 2, all on 2. So I have the midpoint of PR being equal to what? 6 on 2, then here 11 on 2. So the midpoint of PR must be equal to what? 3, then 11 on 2. So that's the midpoint. The midpoint for this PR is what? 3, then 11 on 2. Watch it very carefully. Also, we have to find for what? The midpoint of what? SQ. The midpoint of SQ or QS. So we have the formula there already, so we can just substitute and move on. X1, Y1, then X2, what? Y2. So now, X2 is 4, then plus X1 gives what? 2, all on what? 2. Then Y2 is 4, then plus Y1 is 7, all on 2. So now we have the midpoint of QS equals what? 4 plus 2 gives 6 on 2, then here I get 11 on 2. So the midpoint of QS, we have 3, then 11 on 2, because 2 divides 6 is what? 3. So now we can see that, or we can testify that the midpoint of PR and the midpoint of QS, they are what? The same. They are the same. They are the same. So we can conclude that since the midpoint of PR and the midpoint of what? QS are the same, then we can say that what? The diagonals of the what? Of the parallelogram what? Bisect what? Each other. So since the coordinates of PR, since the midpoint of PR is equal to what? QS, it implies that what? The two diagonals bisect each other. Again, since the midpoint of PR, is equal to what? The midpoint of what? QS, they are equal. Then it implies that what? The two diagonals bisect each other. So that's it. Kindly watch it very carefully. Alright, so let's continue by solving more examples. So it's left with my 2 examples to go. So we move to the next example. Move to the next example. Move to the next example. Example 2. We have find the midpoint. Find the midpoint of the line. Find the midpoint of the line. Joining the point. Joining the point A, 1, 3, and B, 4, 5. So find the midpoint of the line joining the points A, 1, 3, and B, 4, 5. So let's see. Solution. How best can we solve this? So how best can we solve this question? So we are finding for the midpoint. So we have 2 points joining a line together, right? So a line joining 2 points together, A line joining 2 points together, so point A, which is 1, -3, then point B, which is 4, 5, right? So we want to find for the midpoint M, that's XY. We want to find for the midpoint M, that's XY. So what would be the midpoint? XY. So the formula, midpoint, XY is giving us what? X2 plus X1 all on 2, then Y2 plus Y1 all on 2. So we have the midpoint of what? AB, right? The midpoint of AB must be equal to, we have X1, Y1, then X2, Y2. So X2 gives what? 4 plus X1 gives 1 all on 2. Then Y2 gives what? 5 plus Y1 gives what? -3 all on 2. So I have the midpoint of AB must be equal to what? 4 plus 1, which is what? 5 on 2. Then here we have 5 plus -3, which is what? 2 all on 2. So I have the midpoint of AB, which must be equal to what? 5 on 2, which is 2.5, then here I get 1. Or you can leave it as 5 on 2. Then that's it. So therefore, the midpoint of AB, or the midpoint of this line segment AB, is what? 5 on 2, 1. 5 on 2, 1. My last example, then I give you one to try. My last example. So we have the question as shown on the board. Midpoint M47 is the midpoint of the line. So M47 is the midpoint of the line. Joining the points A, X, Y, and B, 6, 11. Find the coordinates of the points represented by what? X and Y. So we start by writing our formula M, X, Y, which must be equal to what? X2 plus X1 all on 2, then Y2 plus Y1 all on what? 2. So now, M, this is X, then this is Y, right? So X is what? 4, then Y is what? 7, which must be equal to, now let's see, this one is X1, this one is what? Y1. Then this one is X2, this one is what? Y2, right? So I have my X2, which is what? 6, plus what? X1, which is X, all on 2. Then Y2, which is what? 11, plus Y1, which is what? Y, all on what? 2. So we have it as that. So now, midpoint M, which is 4, 7. We know that this one is the X coordinate and this one is the Y coordinate, right? And here, for the midpoint formula, we know that this is the X coordinate and this one is the what? Y coordinates, right? So now they are equating, so we can equate them. So we can say that 4 should be equal to 6 plus X all on 2. That's equation 1. Then also 7 must be equal to what? 11 plus Y all on 2. That's equation what? Equation 2. I believe you understand that. So now we are finding X here. So we multiply through by 2. So 2 times 4, which is 8, equals 6 plus X. So we can find X, which is equal to 8 minus 6. Then X equals what? 2. We have this. Then here we can multiply through by 2. So we have 2, 7, 14 equals 11 plus Y. Then we group like tens. Y equals 14 minus 11. Then Y equals what? 3. So now, they said find the coordinates of the point represented by what? X and Y. So you can state that, therefore, the coordinates of the point represented by what? X and Y is what? 2 and 3 respectively. Again, therefore, the coordinates of the point represented by X and Y is what? 2 and 3 respectively. So that's it. Very, very simple. Again, if you reach here, you know your M, which is 4, 7. Your midpoint, they're giving you the midpoint 4, 7. Then here, X2 plus X1. Just take your values, the X coordinates, then the Y coordinate, then substitute it here. Right? So I have 6 plus X on 2, 11 plus Y on 2. Now here, mind you, here is X, here is Y. We deduce this from that, right? We deduce this from that. So we know that this is X coordinates and is equal to this X2 plus X1 on 2. From our what? Our formula. We generated the formula, this formula from that. Okay, then this Y is that, right? Okay, so now we can equate. So this 4 should be equal to that because they are equating. We equate the X and X, then Y, then what? Y. The X value, then the X value, then Y, then the Y value. So 4 will be equal to that, 7 will be equal to that. Then we find for that. Very, very simple. Very, very simple. Very, very simple. So when you are done, you conclude that, therefore, the coordinates of the point represented by X and Y is what? 2 and 3 respectively. Thank you. So now, I'm done. So I give you try works to go and try it yourself, right? So we have home link. Assignments you're going to try. Home link. So I have home link. You're going to try it yourself. Which is one I have we have in the standard xy coordinate, in the standard xy coordinate plane, point M with coordinates, point M with coordinates 5, 4 is the midpoint, of AB, and B has coordinates, 7, 3. What are the coordinates? Of A? What are the coordinates of A? 2. M38 is the midpoint. Of the line. AB. Full stop. A has the coordinates. Negative 2, 3. Find the coordinates of B. So that's that. Thanks for watching. Please do all to subscribe to Masa Tutorials for more of my mathematics videos. Thank you for subscribing. Thank you for watching. I appreciate it. Click on the subscribe button, then subscribe, then like. If you have any problem, please drop it at the comment section. Please make sure that you learn it very, very well. Thank you and have a nice day. Bye-bye.